In this lesson, we're going to talk about displaying data using a special method, the toString method. But it's a short lesson, so let's spend a second reviewing our class so far. So we're keeping track of time. Our private data members are hour, minute, second. Then we have a constructor that's fully parameterized. In other words, there's a parameter for each data member. Then we also have a default constructor that sets each member to its default value, which is 0. We could also have constructors with 2 and 1 parameters. We demonstrated those in a previous lesson, but I'm not going to add them back to the class now. They just add length to the definition we don't need. Then we have the property methods. The property methods allow us to use standard Microsoft .NET syntax to set and retrieve the values stored in the data members. Now, if we had a data member whose value we didn't want to change, we could just remove the property for that member or never define one in the first place. And then finally, we wrote a setTime method so that we could take a previously instantiated object and set the time for it, the hours, the minutes, and the seconds. All right, so now we're ready to look and see how to implement a toString method. toString is a standard across just about every object-oriented programming language, certainly Java and C# and C++ for that matter. The toString method can be written very simply, although we'll have to make some changes once we write it. We write public string toString and then open close parentheses because it has no parameters. The method itself simply returns the data member values, either all of them or whichever ones you want, as a string. So we're going to return the string in hours, minutes, seconds format, the standard format. So we're going to write return hour plus a colon plus minute plus a colon plus second semicolon, and that's all we have to write. It's not that involved. Then we want to call it. Let's create an object. Time, the time equals new time 18:23:0. Now, if we want to display the time, all we have to do is call Console.WriteLine .toString. Let's add console read key. You notice there's an error here. Again, rather than edit this out, I want you to learn from my mistakes. I forgot the parentheses. Other languages don't require those, although they should. So we add the open and close parentheses. Now we're ready to run the program. And so we see the time. And notice we don't have a 2-digit display for the seconds. And if we'd have set the minutes to a single digit, so instead of HH:MM:SS, we get 18, 23, and 0. Later I'll show you how to modify that. We can get 00 to appear for seconds, and that will be more in standard format. Now if we scroll back up to our method, you'll notice that we have a warning underneath it. And it says, toString hides inherited member object toString. To make the current member override that implementation, add the override keyword. Otherwise, add the new keyword. What this means is that there is an object class. And in fact, all of the objects that we use in C#, the built-in objects and the objects that we create, all inherit from that object class. In fact, we can't do much with it, but we can create an object like this. And I can even display its value, which it doesn't really have one, but I can still write toString on that object. When you run it, you get system.object. The point here is that the toString method has already been defined for the object class. So because of that, if I try to reuse a name, a method name that already exists in a class like object, then I have to either override it, which means let's provide a new definition for that method, or I have to use the keyword new saying this is a completely new implementation. By overriding, I'm simply stating that, yes, I know this is a method that's already been defined, but I'm going to provide my own definition. And when I do that, after we run the program, you'll notice that the warning disappeared. So you've learned two concepts in this chapter. Overloading, which means we can have methods of the same name, just with different argument lists, and overriding, which means we can take a method that currently exists for an object that is higher up in the hierarchy than our object is, and we can redefine it so that the compiler will use the new definition of the method rather than the one that comes, for example, with the object class. Now, of course, there are other ways to display data. Very quickly, I'll write another method, although there's really not much reason to use it. We could have written a display time method, which looks exactly like ours, or we could have changed the definition somehow. Display it in AM, PM format, something like that. But my point is that you don't have to use toString exclusively as means of displaying time. So you see I can use display time here, and it works exactly the same. So you can have multiple ways of displaying data. You don't have to just use toString exclusively. But every class you implement should have a toString method. Again, it's expected. All programmers expect there to be a toString method as part of that class's interface. When I refer to the interface, I'm just talking about those methods that we use to interact with a class object. So the constructors, the properties, all of those are part of the interface along with toString and now display time. Those all become part of the time class's interface. So we're free to use or define any method we want, but we should always, as a default, implement toString. And typically, you want it to return all of the data that you're storing in a class object, because a lot of times you'll use toString for debugging purposes more than anything else. Display time is almost a better way to indicate to someone that you're trying to get the time out of an object rather than toString. But toString does make a good method to use with debugging. So those are two examples of displaying the data from a class object. Now let's move to a new topic, and in the next lesson we're going to talk about creating helper methods that are not part of the interface but are part of the internal class definition that help us get our work done.